Acid-base titrations. I'm Mr. B. An acid-base titration is a quantitative analysis of acids and bases. Through this process, an acid or base of known concentration neutralizes an acid or base of unknown concentration. If you know the volume and concentration of the acid or base at the equivalence point or neutralization point, you can calculate the concentration or volume of a base or acid in the unknown solution. This process represents a neutralization reaction. The general equation for a neutralization reaction is acid plus base yields salt plus water. The titration formula is written as follows, where Ma times Va is equal to Mb times Vb, where Ma represents the molarity of the acid H+, Mb represents the molarity of the base OH-, Va represents the volume of the acid, and Vb represents the volume of the base. Or more specifically, we may write MaVa divided by Na is equal to MbVb divided by Nb, where Na and Nb represents the moles from the molar ratio in the balanced chemical equation. Practice problem 1. It takes 83 milliliters of a 0.45 molar NaOH solution to neutralize 235 milliliters of an HCl solution. What is the concentration of the HCl solution? We begin by writing the balanced chemical equation where HCl plus NaOH produces NaCl plus H2O. The molar ratio for the reaction will be 1:1:1:1. However, we're only concerned with the reactant side of the chemical equation, so the molar ratio will be 1:1. We now use these values in the titration formula, where the denominator will be all ones. Inserting the information from the practice problem yields the following. X molar HCl times 235 milliliters divided by 1 mole is equal to 0.45 molar NaOH times 83 milliliters divided by 1 mole. Solving for x, we get the following, where x is equal to 0.45 times 83 divided by 235. This represents the numerical setup. Solving for x yields 0.159 molar HCl. Practice problem 2. It takes 12.5 milliliters of a 0.30 molar HCl solution to neutralize an unknown volume of a 0.15 molar NaOH solution. What's the volume of the NaOH solution? Since this is the same chemical equation as before, we skip directly to the titration formula, where once again ones are written into the denominator. Entering the information, we yields the following relationship, where 0.30 molar HCl times 12.5 milliliters divided by 1 mole of HCl is equal to 0.15 molar NaOH times X milliliters divided by 1 molar NaOH. X is equal to 0.30 times 12.5 divided by 0.15. This once again represents the numerical setup. And the answer will be X is equal to 25 milliliters of NaOH. Practice problem 3. It takes 38 milliliters of a 0.75 molar NaOH or sodium hydroxide solution to completely neutralize 155 milliliters of a sulfuric acid solution, H₂SO4. What is the concentration of the H₂SO4 or sulfuric acid solution? We begin by writing the balanced chemical equation, where 1 mole of H₂SO4, sulfuric acid, reacts with 2 moles of NaOH, sodium hydroxide, to produce 1 mole of Na2SO4, sodium sulfate, and 2 moles of water. The molar ratio will be 1 to 2 to 1 to 2. However, since we're only interested in the reactant side of the equation, we use the ratio values 1 to 2. Inserting these values into the titration formula yields the following. MA/VA over 1 is equal to MB/VB over 2. Substituting the values from the practice problem yields the following relationship. X molar H₂SO4 times 155 milliliters divided by 1 mole is equal to 0.75 molar NaOH, sodium hydroxide, times 38 milliliters divided by 2 moles. Simplifying the relationship yields the following. 2x times 155 is equal to 0.75 times 38. And x is equal to 0.75 times 38 divided by 2 times 155. This represents the numerical setup. And x is equal to 0.092 molar H₂SO4. Practice problem 4. If it takes 25 milliliters of a 0.45 molar H₂SO4 solution to neutralize 35 milliliters of AlOH3 or aluminum hydroxide solution, what is the concentration of the aluminum hydroxide solution? The balanced chemical equation for this reaction will be 3 moles of H₂SO4 plus 2 moles of AlOH3, aluminum hydroxide, yields 1 mole of aluminum sulfate, Al2SO43, and 6 moles of water. The molar ratio will be 3 to 2 to 1 to 6. But once again, we're only concerned with the reactant side of the chemical equation, so we use the ratio values 3 to 2. Inserting these values into the titration formula yields the following. MAVA over 3 is equal to MBVB over 2. Inserting the values in the practice problem yields the following equality, where 0.45 molar H₂SO4 times 25 milliliters divided by 3 moles is equal to X moles of AlOH3 times 35 milliliters divided by 2 moles. Simplifying yields the following relationship. 2 moles times 0.45 molar times 25 milliliters is equal to 3 moles times X molar times 35 milliliters. And X is equal to 2 times 0.45 times 25 divided by 3 times 35. This represents the numerical setup. And X will equal 0.214 molar AlOH3 or aluminum hydroxide. This concludes my lesson on acid-base titrations. I'm Mr. B.